So many of our customers start to approach their problem statements with this like preconceived notion of here's how the solution's going to work. Like this is what it is. And we often have to kind of like break that down and say, no, we're actually going to start with like the problem statement. Like what are you ultimately trying to solve for? Typically a customer generally has an idea of like what they're trying to solve for. And it is framing the whole solution, the technology around that problem statement, around that business objective, right? To make sure that is the focal point for like everything we're going to do. You often don't know what you're actually going to end up with at the end.
My name is Madeline Castillo, and I'm the CMO here at Tulip, and this is our video series, Humans in the Loop, where I speak with the folks behind the product. And I have a couple of colleagues here with me today. Why don't you introduce yourselves?
Hi, I'm Gilad Langer. I lead our industry practice here at Tulip.
And hi, I'm Geoff Winkley, Solution Delivery Lead.
One of the things I love about the examples you guys have been bringing up is they're very solution-oriented. Like we're talking about using generative AI, whether we're using agents or like we're getting context from some sort of like chat generation or composition function, but it's really in the context of I have this thing that I need to do to solve this big question that impacts my operation. And that can be hard to kind of translate to people, right? Like this is a platform level technology that enables this type of solution design. Can you talk through a little bit about solution design and like when and how to kind of start using tech, or how you're seeing customers start to use a technology provided by Tulip versus like something else to solve these problems?
Yeah. I think one of the kind of first use cases that we're really seeing is just simply to take existing work instructions and documents that exist in a paper form, likely on a PDF, most likely Microsoft PowerPoint, and take that and put it into a dynamic application, right? So, what could be upwards of, 10 minutes per page just to like transcribe, organize that paper content to a, digital application can now be done in a matter of, seconds, right? So I think that's kind of like one of the very early first use cases that we're starting to see our customers actually do. Because if you're starting with this piece of paper and you want to have a lot of the same content, inside of your digital application, first thing you need to do is get it there.
Sure.
And as opposed to spending hours doing it, one click, it's transcribed.
Yeah, I talked yesterday to one of our partner team. We have a customer there's a guy who has a 600-page document that basically defines how you produce, and I can't remember what the product was, with references like, from if you go to this page, you have to go to page 155, and then you'll find, it's like, it's like, the whole manual. And it's like, how do we get that? Like it was like, it's pretty simple. You feed it into our composer. So the basics say, prompt him to read all of this and create actual distinct work instructions with pictures and everything. It has pictures in it as well.
Yep.
As a way to do that. And again, that's the intern, right? So you just hired an intern to go through the 600 pages and basically do that.
Yep.
But at a core, when we start talking about digital technologies and agents, now in manufacturing, we talk about solutions. Why? Because we're all engineers.
Yeah.
And one of the things that makes manufacturing, manufacturing is complicated and complex because of systems, but it also sometimes more complex than it needs to be because it's managed by engineers.
100%.
So,
100%.
engineers, everything, we're engineers, and engineers are solution oriented.
Sure.
And that's kind of everything that we drive, and I get slack for it from my family all the time.
Yeah.
They just want to talk about it. They don't need a solution, right? I get that all the time.
Everything is a highly complex maximum optimization problem.
Exactly. And manufacturing works this way, and we can't get away from that because they need to. So we need to provide to the industry also methods that help them to create the digital content or frameworks for agents. And that's a lot of the work that I do at Tulip is put in methods. So when we go and try to solve something, we have to, we use a method. And this method is not something that most engineers have seen before, because it's kind of a mishmash of three things, actually, how you do software technologies. And I'm not talking about Agile and other stuff, but these are long, more in-depth, how you do things how you design things in manufacturing.
Waterfall approach, or?
Yeah, well, waterfall Agile that's the third, and that's where engineers actually fail. See, if you think about Agile and continuous, and this is what I call the genius of the Toyota production system. What's a Kaizen event? What's continuous improvement? If you think about it, it basically leans on the way that humans creatively solve problems. How do we solve a problem? How does a baby learn? By trial and error, right? We try something, it doesn't work. We try, it doesn't work. That's how we as humans operate. And that's what continuous improvement basically has taken and established as a form of like a method. Agile and software development is essentially the exact same thing. They actually were born more or less at the same time. We're marrying them together with a framework of how to apply that to digital technology and an agentic framework. So part of what we're doing is helping the industry understand how to apply this technology in the right way, in the right domain, because we know we're in a manufacturing plant, and in a manufacturing plant, certain things apply. It's not, we're not selling shoes or treat patients like we are supposed to manufacture.
Yeah.
So that's the easy part. Like, it's actually pretty well defined.
I have a follow-up here. I mean, you talked about kind of the different components that make Tulip's kind of platform approach helpful for this type of operation and continuous improvement, and also well-suited in some ways, or a lot of ways, to things like agentic AI because of the composability, because of the kind of integration with partners. But we've talked a lot, I think, when thinking about use cases and adoption, about manufacturers that are still in that they're starting to go digital phase. And I'm curious, just give us some comparison context. If I'm a manufacturer that went digital with a monolithic MES, and now I would like to gain value from leveraging generative agentic AI, what are some of the things that I'm going to face or hit up against trying to make that transition, or what's a good comparison of that versus a platform kind of like Tulip in adopting that technology and kind of having more of an agile approach?
Yeah. So this is part of our method, right? There's three distinct things that you have to be aware of that are very, very different, and you have to understand the difference, and also understand that really it's about classifying the technology. I put it this way: digital in a manufacturing perspective only matters if it gives you an increase in productivity. We call it an order of magnitude productivity increase.
Okay. Because
these revolutions in manufacturing, and we are in one, every time that happens, our level of productivity increases 10, 50, 100-fold. If you don't see that improvement, you don't see that productivity improvement, then if your technology is not capable of giving you that productivity improvement, it is not digital technology, kind of it is. And one is that it is not hierarchical. It's not top-down hierarchies. A lot of the traditional MESs are built on ISA 95 types of hierarchies, which are in their infrastructure are top-down hierarchical, and in the way they exert control, in the way that they let you manage this is top-down.
Okay.
And that means that you have to, in a way, hard code into the system how your plant runs. And as soon as your plant deviates from how you said it was going to run, which happens 3 seconds after they put the system in, it doesn't work. And then you have to revert to workarounds. That's one thing. The next one is human-centric, right? Traditional systems that the majority of manufacturing use are systems where an operator needs to serve the system. I need to stop what I'm doing, and I need to go to the system and tell it what I did. We are turning things around here, because everything that you use think about any digital technology you use in your everyday life. And again, I bring my kids as example. They'll install an app on their phone. If they don't intuitively, that app doesn't help them do what it's supposed to do, it's off. It's done, right? 30 seconds. It gets 30 seconds, otherwise it's out.
Yep. And how much training was there to use the app?
Yeah. Exactly.
None.
By the way, that is twice a day. I get it from customers, especially the big ones. Okay, where is your training, and how many weeks do we need to put aside to train the operators in using the apps? And I go, you don't need to train the operators to use the apps. And then we just get, deer in the headlights, kind of blank, the TV goes blank.
I have never taken a Google Maps course. Yeah, I am an expert in how to use Google Maps.
And then the last thing is the process-centric, right? So, these systems at the time, that was the only way to do it. And it was pretty novel. You kind of define workflows and process flows, and you kind of execute on those. And again, here we are looking at human activity. We're actually looking at what people do on the shop floor. So those are the things, and you have to really use those, the kind of this, to understand whether your technology is new or not. It gives an example of agentic AI, right? I mean, an agent, you don't need to define the process for an agent. It will know it itself. If you give it the right data, of course.
Can I add one more pillar, 2 or 3? a lot of these legacy systems are not built on an open architecture and open ecosystem. And inherently, these AI tools are not going to be able to interact with these systems if it is a closed black box. And I think that's one of like the key points that people need to understand and this goes in both like getting data out of the system to make meaningful insights, but also for potential AI agents to influence the system, through data creation, work instruction authoring and things like that. It has to be built on an open architecture, integrating with modern protocols in order for these systems to actually be useful with this wave of AI technology.
You mentioned straight away, you said one of the buzzwords was unstructured, which
Yes.
is the opposite is structured. These old systems are hyperstructured. They are like, the traditional engineer that sits there in that spreadsheet and makes sure that everything is structured the right way and everything is, actually AI doesn't like that. It doesn't like that super deep structures. It wants to be flat. It can actually gain, and that's part of it. And telling an engineer that unstructured, I mean, you're playing to his biggest paranoias. Like it's a problem for us. We like structure, right?
So I shouldn't have standard work to load my dishwasher?
There you go.
Okay.
I'm glad that you gave this example, this Geoff, because I was just about to ask. You have a background in manufacturing. You work with manufacturing engineers and manufacturers all the time. Help kind of the same question as Gilad, but more, customer focus. Like, how do you help them understand maybe old world versus new world when there's not necessarily a one-to-one comparison, so that they can see how it would benefit them and from a solution and value perspective?
Yeah. So I think what you just ended that question with is really a key point, is like the value side, right?
Yeah.
So many of our customers start to approach their problem statements with this like preconceived notion of, here's how the solution is going to work. Like, this is what it is. And we often have to kind of like break that down and say, no, we're actually going to start with like the problem statement. Like, what are you ultimately trying to solve for? Being the position I'm in, typically a customer generally has an idea of like what they're trying to solve for. And it is framing the whole solution, the technology around that problem statement, around that business objective, right? To make sure that is the focal point for like everything we're going to do. You often don't know what you're actually going to end up with at the end. And this is kind of, one of those pillars of composability, that we've discussed before. And so that is like the key point. And I think even when we are adopting these AI tools, it is all about, what are you actually trying to get out of it? What are you trying to solve for? You're not just going to be creating agents just to explore the technology. It has to be around doing something that's going to give you those productivity improvements. And a very like elementary example that we're doing today, right, in the tool platform is, the simple task of creating a chart or an analytic, right, to visualize your data. Before, what we would do is you would have a data set, and then you would go in and try to, create a visualization. You're thinking about, hey, what do I want my x-axis to be and my y-axis, and what series am I going to apply to this? And okay, I need like this field and that field. And I need to do some like calculation and combine these two fields. That is staying focused on, the nitty gritty parts of the solution, when you're actually just trying to get the insight, to the knowledge, the wisdom actually at the end, right? So we flip that around, and what these AI tools are enabling is to go into that data set and simply write out the question that you want answered. How am I trending on my defects week over week over the last 3 months? And then you get that visualization. I mean, that right there is like a number one application of the technology that we're using today, but also almost like an analogy of that kind of problem statement you laid out, where thinking about, staying focused on your business objective as opposed to just, being hyper focused on the solutioning side of things.
So that opens up for this, I'm just going to bring back, so why does that work, and why we have an issue with that, right? Engineers are trained. So I myself am at fault here because I educated engineers way back in my past, but
Part of the problem.
Good, I'm not responsible.
Kind of system theory, but we know engineers are trained to take a problem and break it up into its elements,
Small
to try and come up with a
components,
solution. We all think like that, and it drives a lot of the behavior and a lot of your questions, like how do we, we have to come to the table and with our customers understand that is, you can't break that up. That this is years and years, and it's hundreds of thousands of years of consolidation. If you go to a plant like it has engineers, that you have to say like, it's kind of wrong, right? And so what you said is, this is the approach we're saying is like, rather than, because to get to the solution, we have agents and now we have help. So it's much more important to frame the problem we're trying to solve, right? And guide everybody to the problem. When you do that process, if you look at biological systems and social systems, it's called emergence. When you think about any social organization, right? We put people actually what makes us humans is that if you take a group of people and you give them a problem to solve, they will naturally work together, and kind of, find to solutions to their problem. It doesn't have to be an engineering problem. And really, that's called emergence, and that's what we're trying to foster. I'll give an example of a biological system, a plant. We have plants here. If you take a plant, a seedling, nobody sat there, an engineer didn't sit there and actually do a CAD model of exactly how that plant is going to be. That's how we manufacture. We basically say, okay, we draw exactly how this is going to be. And that's the biggest issue especially in aerospace and defense is the gaps. Well, it's not exactly the way, and you kind of document the deviations. Then if you put the seed in and it starts growing and its objective is it's trying to go to the sun, right?
Yeah.
You just cover it. You put something in the middle. It'll go around, and that's not something that was in the CAD drawing, right? That's adaptability. And that comes from emergence. And that behavior, that the mechanisms around that concept is super important because that's where agility comes from. That's where adaptability comes from. So, and again, back to the Toyota production system, the genius of the production systems is that they actually, if you really analyze some of the tools that they brought in, the Kaizen, the pull versus push, they actually all try to build on those mechanics of emergence to create adaptability, to give you agility. And so understanding that and understanding concepts, and now we're applying them. So Agentic AI, what we do in Tulip is basically giving you tools to help you foster. So number one, in terms of like, how do you design these systems? Objective. Identify objective and make sure everybody understands the objectives. That will drive emergence, right? So I know I'm going to be theoretical, but here's the thing is when you see that in action, when you actually see how a group of people in a manufacturing plant create the app to actually solve the problem and how fast it goes and how little input we have to give to get there. Nobody drew anything up. Nobody created master spreadsheets and entity relationship diagrams and all that. It's just astounding. And you're like, that's theory and practice. And that's what we see in our everyday.
Yep.
Well, I think that's a great kind of closing thought. Thank you guys so much for such a stimulating conversation about the transformation of operations and emergence of generative AI.
Thank you.
Thank you, Madeline.
Thank you.